Hello! Have you got a radiator or a whole group of radiators which aren't getting very hot? Or maybe you have to keep bleeding your radiators. Perhaps you can hear water trickling around your central heating system. Maybe your boiler's bumping and banging, or it keeps tripping out with an overheat fault. All these problems and more can be down to a blockage where your loft tank joins onto your central heating system. Now, you're only going to get this problem on a traditional system and not a combination boiler or a traditional system where you have a pressurized system, so you top it up with a filling loop. But if you have a loft tank that fills up your central heating system and your system's getting a little old, there's a good chance that you have a blockage where the F&E pipe, that's a feed and expansion pipe, joins onto your central heating system, and that can cause all sorts of problems, and it's a fault that readily occurs on our older system. And I'm coming across this problem more and more as our heating systems and houses get older. So in this video, I'm in a property around 65 years old. The boiler kept tripping out with an overheat fault and the radiators downstairs weren't getting very hot. And this system has that blockage which I'm talking about, so I'm going to show you that, along with some other problems which this system had, which you can also sort out at the same time if you're going to investigate this problem for yourself on your own heating system. Now, I'm going to need to drain the central heating system to carry out this work. Now, I'm not going to cover that in this video, but of course, I've made a couple of videos on how to go about draining the central heating system, and especially if you can't find a drain valve, and I'll leave one of those videos linked in the cards above now, or you'll find them down in the description. In the description, I've left links to other videos I've made which are related to this problem. So if this isn't the problem you have, then maybe one of those will help you out. And of course, I've left lots of other useful links in there as well. So do check those out. As usual, there's useful information right to the end of this video. So do try and stick around to the end if you can. Right, now let's get on with the video and remove this blockage. So here's the boiler, and this is a Glowworm Flexicom 15HX. And the boiler is installed downstairs, and above the boiler is a filter. So I can easily drain upstairs by connecting a wash machine hose onto the filter and open it up to a drain outside. Now we're going to have a small loft tank on this system, and we're going to need to stop the system from refilling. The easiest way to do this is just to tie up the float valve. So put a piece of wood across the tank, use a piece of string. In this case, I'm using solder because it's nice and bendy. And I can just tie that around a piece of wood, pull up the float valve to stop it from refilling the tank, and then make sure it's nice and secure. I can then drain the system of water. I've got this loft tank isolated using some bungs. But what I wanted to show you was what's inside the tank. Look at this weird gooey stuff. Now, we don't want any dirty stuff in our loft tank running down through the system, because that might give us more problems. So it's a really good idea to clean your loft tank before you do any draining of your system. Now I've removed the gooey stuff, I'll give it a good wipe out. And there we go, we now got a nice clean tank. So I've removed the bung and I can drain the system. Now this system has a gate valve on the feed pipe, so I can isolate the system from there. So here's the airing cupboard with the hot water tank in, and the pump, the mid position valve, and the mains electrical isolation switch. Now the two pipes that we are interested in are the feed pipe and the open vent pipe. That's these two pipes here. One is 15mm and the other is 22mm. And they come down and they connect onto the central heating system just before the pump. Here they are from a different angle. So we've got the 22mm open vent pipe on a compression fitting on the bottom. Then we got the feed pipe on a 22mm 15T just above it. And it's these two connections we want to get to and investigate. Now I'm just looking at this pipework and trying to decide the best way to go about taking it apart. So this is the pump here, and I can see that this pump valve here, this is definitely not going to come apart easily, so I'm not going to bother with that. This is kind of fixed in position because of the way everything else is, so I can't even undo that nut and lift it off. And I can't do anything underneath the pump because, again, the way the pipework is connected. So what I'm going to do is use my junior hacksaw and just cut through the pipe just there above the pump. And then I'm going to see if I can undo one of these nuts on the bottom here. But first of all, I'm going to manually open up this motorized valve to make sure it is in the mid position and there's no chance of an airlock and water being trapped in this part of the system somewhere. With the power off and the fuse removed, I can now safely work on the system. And I'm now just about to finish cutting through the pipe just above the pump. There we are. So I'm going to try and undo this nut here, because I can see it's been leaking, so suggesting maybe it's not as tight as it should be. Now, when you undo compression fittings, you always want to support them. So I'm going to get a second set of spanners and support the fitting as I undo the nut at the top. And there we go. Like I thought, that turned quite easily. So I can now fully undo this nut. Now, I'm not going to be able to lift off the pump because the feed pipe is still holding it in position. Because that feed pipe is so hard to get to, I'm going to cut through it further up the pipework because that's nice and easy to get to. So I get my 15mm pipe slice and cut through the feed pipe which comes from the loft tank. And there we go. So the pump's still not coming out, so I'm going to cut through another pipe, undo a fitting, and then hopefully it will then come out. So I'm going to cut through this 15mm bypass pipe here. Undo the nut here on the mid-position valve. I can then remove this little bit of pipework. Now let's take a look inside this 22mm tube and see how much magnetite there is inside there and whether it's at all blocked up. We can't see all the way through it because of the bends, but it's not that bad to cause a problem. Now I should be able to lift the pump off that bottom T there. And there we go, that's it now removed. But I'm still going to have to cut through the feed pipe, which is going to be trapping it in this position. So I've now got the pump out, and I've just had a chat with a customer because we can see that the pump has been replaced once before because there's two different coloured reds of the pump. Now I want to take this bit of pipework apart here and show you what's inside it. So I want to see how much magnetite is actually blocking this part of the pipework up. I'm now going to undo the screw which holds on the cover so I can then remove the electrical connections. So remove the electrical connections from the old pump. Something else I want to point out to you, if you're looking to do this work, you can see that both the pump valves are still connected onto the pump. And that's because there's absolutely no chance of undoing those nuts that are on the pump. You can see where water has been leaking out and you've got all that corrosion and limescale built up. So the only way to remove the pump and leave the valves in place on the system is to cut through the nuts. And I would use a junior hacksaw to do that. I think I'll make another video on how to go about doing that. I'll leave it in a link below. Just to demonstrate that, you can see I'm now going to stand on the pump and I've got my adjustable spanner there and I'm trying to undo that nut which is on the pump valve. So I've probably got absolutely no chance of undoing them in the cupboard. So now I've managed to undo that nut here on the pump valve and I can remove this bit of pipework and we can see exactly how much magnetite is inside this bit of pipework. Now it's not quite as bad as I thought it was going to be, but there is quite a significant amount of magnetite all the way around that bit of pipework, right the way through it. Let's take a quick look at the valve on the pump and see if there's any magnetite inside there. And yes, we can see there's quite a bit of magnetite which is built up around the edges, reducing the size of the hole which is going into the pump. Now this is a brand new pump valve and of course this is what our hole should look like going into the pump. But you can see there is magnetite all the way around the edge here, just reducing the size of the inlet. Now I'm curious to see how much magnetite is actually going to be stuck inside the pump. So let's just take the pump head off and have a look at the impeller. Give it a couple of taps to break it apart. And now we can take a look at the impeller. Now straight away I can see there's a big chunk of magnetite right sat in the middle there. So I'm wondering where such a large chunk has come from. It must have broken off somewhere and it's got lodged in the pump. Now on first look it doesn't look too bad. You can see there's bits of magnetite in the veins, but let me show you how bad it actually is. Now as I poke my screwdriver up through the vein there, look at all the magnetite that's being pushed out. There's loads of magnetite blocking each of these veins up, making the pump virtually useless. Let me give you a quick explanation of how the pump actually works, in case you're completely new to water pumps. So the pump is an electric motor, and it spins this impeller around very quickly. And we can change the speed at which it spins using the settings on the pump. And you should know if you spin anything around and you let it go, it flies away from you. And that's basically the way the pump works. It spins around, the water is free moving, and so it flings it out to the side. So it gets sucked in the middle and it gets flung out through the sides and the water flows around your system. So all of these bits of magnetite have got sucked in the middle and then they get stuck in the vanes, reducing the efficiency of the pump or stopping it from working altogether. But the pump does continue to spin, but it's going to have very little flow. Anyway, that's enough fiddling around with this pump. We're not going to keep it, so let's just bin that. But you can see how much magnetite has built up inside in every vane. I hope you found this video useful so far. I want to quickly jump in here and introduce myself. My name is Mark Ballard and I've been a gas registered engineer for over 30 years. The aim of my channel is to help you with your gas boilers and your central heating. If you find this video at all useful, then please give me a little bit of feedback by clicking on the old thumbs up and subscribe. That will help others to find the video, and of course share it with anyone else who may be interested. If you visit my website, I've categorized all my videos and products and parts that I recommend so you can easily find what you're looking for. And I'd like to say a really big thank you to everybody who's bought me a cup of coffee and left me a donation in my Toolbox fund. It's really appreciated and it does really help me to make more videos which will hopefully help you. So I'm going to replace that pump with this brand new Grundfos UPS 3 1560/65-130. Grundfos is well known for being one of the best pumps on the market. You'll get a little book of instructions, electrical connection, and 2 flat rubber washers you'll need for the valves. Now, before I fit the new pump valves onto this pump, I always smear a little bit of silicone grease onto the threads of the pump. I do this just in case I'm ever going to come back and need to remove the pump, because it makes it so much easier to undo the valves. If you decide to do this, you must not get any of that grease onto the washer or the flat surface of the valve and pump, because then the rubber washer won't stay in place as you do the valves up, causing a possible leak, and no one wants a leak. If for any reason you need to remove some nuts which may be been held on by an olive, you can use your long nose pliers like that and lever against the fitting, or you can get your adjustable spanner and just tap against the nut and hopefully that'll push the olive off like that. But of course, you can always check my video out, 5 ways to remove an olive. Now I wanted to show you this bit of pipework again. You can see with my torch there is some magnetite blocking this part of the pipework up. This is where the feed pipe from the loft tank connects onto our heating system. And you can see there's magnetite inside there. Now the question is that little bit of 15mm blocked up? So let's take a look. You can see I've cleaned out that bit of 22, but how about the 15? Do you think that's blocked up? Well, let's just put some water down that 15mm tube and then we should see it running through and coming out of the 22mm. But it's not. Look, you can see that that bit of 15mm pipe is completely blocked up. There's no water flowing down that pipe at all. So just to show you guys what you may find, I've cut this bit of pipe work so we can have a look inside it. And you can see there's magnetite built up inside that T there. It looks pretty bad, but it's not completely blocked. But when we look in the rest of the tube, you can see it is completely blocked up with magnetite. You can actually see the different colors as the system's got worse to where it is now, where it's very red in there, meaning there's a lot of rust going on inside the system. As this video is about blockages, I wanted to show you how strongly this magnetite is bonded onto this 15mm pipe. No amount of cleaning and chemicals is going to get this out. You can only do it manually. But basically, you're going to have to just replace the piece of pipework. And I'm using a pointy bradawl here, and it's really hard to get it off the sides. Now, this blockage doesn't just suddenly appear. This is a buildup of magnetite over years and years and years. And once this feed pipe starts beginning to get blocked up and reducing the amount of water that can flow up and down it, when the pump starts running, it then starts sucking air back down the open vent pipe. That air contains oxygen. The oxygen goes around your system, rusts away your radiators, creating more magnetite, escalating the problem really quickly. If you have this problem, then you may hear water trickling around your system because air's being drawn in. You might need to keep bleeding radiators. And like I said, that air contains oxygen. Oxygen, steel and water create rust. And we can see that that is happening on this system because the magnetite in the middle of the pipe is red, meaning it's fresh rust. Now, quite often the open vent pipe won't be too blocked up with magnetite. And I'm going to see what this one's like because I don't really want to take it apart. So I'm going to give this open vent pipe a good old clean and see how it looks afterwards. Now let's take a look at that open vent pipe, and that looks a lot better to me. I don't think there's any need to take this fitting here apart. And just remember, the entire system, all the pipework, will have magnetite coating the inside of the pipes. So there's a limited amount of manual cleaning that we can actually do. Now I'm happy I've removed all those problem areas. It's just a case of rebuilding everything. So make up some new pipework. Solder up a new feed pipe. There's the good old smoke alarm going off as I finish off this feed pipe connection. Then a little more soldering. Now I'm using joining compound on these compression fittings. And if you'd like to know a little bit more about compression fittings, then I made a video showing all the ways that you can make compression fittings up. And I'll leave that linked in the cards above now. So now I've rebuilt all that pipework, and all I need to do is to fit the new pump. So here's the new pump in position, and I'm just doing up the pump valves. And finally do up the large union nuts onto the pump. Now I just check that both pump valves are fully open, which they are. And there we go, I'm ready to refill the system now. Open up this feed gate valve, and that's going to let the water into the central heating system. Whilst the system's filling up, I can then get the electrical plug which goes onto the pump, and I can wire that up, ready to plug it into the pump. That's all wired up now, and I can plug it into the pump. And then give the whole area a bit of a clean off. So there we go, the system is now back up and running again. There's no more sound of water trickling around the system. The radiators downstairs are nice and hot, which they've not been for a long time. The boiler sounds much happier, and it's no longer tripping out from overheating like it was before. Now just saying here how the whole system is back up and running again, but ideally the whole lot was to be taken out and started again. You've got a tank here that's not properly lagged. You've got incorrect pipework at the top here. And there's a whole multitude of different fittings that have been used. But this has probably been here since the house was built, which was some 65 years ago. And of course, we can only do what the homeowner can afford and wants to do. Now I just need to remove my drain hose from the top of the boiler, add some inhibitor, and I've advised the customer that they should get this whole system flushed through. If you're still watching now and you're wondering why I didn't use that drain valve, well, again, I've made another video all about the problems with drain valves and the best ways to go about draining your system. So did you have this blockage on your central heating system? Do let me know in the comments. It's always great to get your feedback and see what people are doing and finding. Your comments can also help other people who may be having similar issues. Right, that's about it then. So I do hope my video has been helpful to you. If you want to watch another video on the same fault on a different system, then you can click on that link just there. If you want to know how to drain your system without even using drain valve, then you can click on that link just there. As usual, please give me some feedback by clicking the thumbs up, click on subscribe, share it with anyone who may find this video useful. And of course, a cup of coffee in my toolbox fund is always really appreciated. Bye for now, and I hope to see you in the next video.